So your test is put together. There's going to be a few multiple choice questions. I bet you lots of those will be conceptual questions about Newton's laws, or whether you would feel lighter or heavier in an elevator, depending on which way the acceleration is. Or so a lot of the thought puzzles that I've given you, but not as tricky as the ones that I've started class with, more of the common sense ones that I've tried to do throughout the lesson. Then there's going to be a couple of questions about the net force. The what force? I'll probably just give you a mass and give you a force and say find an acceleration, just to see, can you rewrite F equals M, F net equals ma? Then we will get into written questions. There's definitely going to be an object being pulled to the right by an applied force with friction. There's definitely going to be something hanging over a cliff. And there's definitely going to be an Atwood machine. So let's analyze this Atwood machine. This is a job for a free body diagram. We're going to have M1G tension, M2G tension. Which force is going to be the winning force? M1G or M2G? And how do you know? Pardon me? For the Atwood machine, it's going to be the heavier force. So I often will just make a little note, Jimmy, A is that way, because it's not like I've ever forgotten partway through the question and suddenly picked the wrong winner. So who's winning? And then I'm going to have minus tension, plus tension when that tension comes around to the other side and I follow it, minus M2G, that equals M all A. I would relax. I would get the A by itself. A is going to be M1G minus M2G all over M1 plus M2. A is going to be 21.3 times 9.8 minus 19.6 times 9.8. all over 19.6 plus 21.3, or 21.3 plus 19.6, doesn't matter which order I write those ones in the bottom. You might recall I made some predictions. I said these two masses, Ethan, are almost identical. Who remembers for identical masses what was the acceleration in the Atwood machine when the masses were identical? Yeah, we proved that. Since they're almost identical, you got a really small acceleration. In fact, I'm betting is it less than 1? Yeah, I can make that prediction and have a built-in error check ahead of time. So let's actually crunch the numbers. If the masses were very spread apart, then I would be expecting a bigger acceleration. Bracket 21.3 times 9.8 minus 19.6 times 9.8, close bracket, divided by bracket 19.6 plus 21.3. Did you get 0.407 meters per second squared? If you got that right, I would give you 4 out of 4. Otherwise, I would probably give you 1 mark if I saw that, 1 mark if you got the A by itself, 1 mark for the numbers, and 1 mark for the answer. Find the tension in the cord. I'm going to use mass 2. If you used mass 1, I'll show you how you would do that. But because tension was winning for mass 2, I chose to go M2G minus tension. Sorry, let's try that again, Mr. Dewick. I chose to go tension minus M2G equals M2A. And remember, the way I remember this is for an individual force, I look at an individual mass. I plus that over. I got tension equals M2A plus M2G. M2 was 19.6. 19.6 times answer button plus 19.6 times 9.8. And I got 200. And I think I told you 19, these are both about 20 kilograms, which is both of them around 45 pounds. There's about 90 pounds hanging here. I said, I'm expecting a fairly big tension. I said, if I got a tension of like 10, I'd be nervous. Is that right? 200? Even? Almost even? If you got that 3 out of 3, how many of you used mass 1? Okay, so you would have M1G minus T equals M1A. You would have T equals M1G minus M1A, and you still got the 200. Yes? Okay. If you used Mass 1 and you didn't get the right answer, show me your work later, and I'll tell you what the part marks would be. Otherwise, I would give you 1 mark for that, 1 mark for that, and 1 mark for the answer. So I'll probably give you an Atwood machine, and I'll probably make it worth a chunk of marks because there is a fair number of steps. This is a multi-step question. Is that okay, Hayden? How many got that one right? So I'm hoping that's close to free marks then. Ooh, I like number 2, I like number 2, I like number 2. Example 2 isn't it? I'm going to give you a question where I muck around with the normal force, where either something else is lifting up or something else is pushing down. Still a job for a free body diagram, although I'm going to label the picture here. mg. Is the normal force here bigger, smaller, or the same size as mg? You know what? It's not the same size because there's an extra vertical force. So is the normal force bigger or smaller than mg? Smaller. Why? Because 19 newtons worth of mg is being taken care of by that upward pointing arrow. So I'll exaggerate it. Then I have F applied. Do you have the quiz? I didn't give it to you. I thought I did. Did you lose the quiz? Probably. Do you have the other notes somewhere? Okay. Oh boy. We'll find out. And friction. Who's winning? Well, it's going to be friction. No, friction, Mr. Dewick? Geez. F applied minus friction equals MA. And so I'm going to get A equals F applied. Why am I writing friction every time? Dewick. Minus friction all over M. I'm about to make a mistake. Tell me when you see the mistake. Don't write this down. What's the mistake? The normal force is not mg in this case. Okay? You might have put mu times the normal force in on this line, but Ethan, because there's an extra vertical force, I've got to calculate the normal force. So are we sinking into the ground like quicksand? Are we flying into the air like Superman? What that really means is everything up, which is the normal force plus 19, has to equal everything down, which is mg. How would I get the normal force by itself in this little mini equation here? Yep. And so you have a choice. You could crunch that if you wanted to. You could actually go 3.6 times 9.8 minus 19 and just stick that 16.28 in for the normal force. Or you could put the whole algebraic expression right there. I don't care which method you use. I'm going to get this 12 minus 0.48 bracket 3.6 times 9.8 minus 19 all over 3.6. I'll do this in one step, but you didn't have to. 12 minus 0.48 times bracket 3.6 times 9.8 minus 19, close off the top, close off the small bracket, close off the top, divided by 3.6. You'll get an acceleration of 1.16. Am I seeing nods or no? Yeah? Meters per second squared. I would give you 3 out of 3 if you had that. Otherwise, 1, 2, 3, 4, 5. I would probably go half mark for that. Half mark for that. I would go a half mark if I saw that somewhere. Half mark for that. Half mark for the numbers. And a half mark for the answer. And then I would go to the next page. What would the accelerate? Well, who's winning, F1 or F2? So I guess it's going to be winner minus loser equals MA. You know what? I was so lazy, I just did that. In fact, I was so lazy, I just got my calculator out and I said, they told me F1, 60 minus 36 divided by, they said the mass in the question is 12. I probably could have done that in my head. B. Yes? 1 mark. I told you that I wanted you to draw the free body diagram for this right here. So, what are the forces acting on this mass? Get the obvious one. What else? Is the normal force going to be bigger, smaller, or the same size as gravity? Okay, and I would look for that. What if I was doing the question on the previous page? Then I would look for a normal force smaller. What if there was an extra force pointing down? Then I would look for a normal force bigger, exaggerated. But here, I'll eyeball it. They should be about the same. Then there is an applied force. What else? Bigger, smaller, or the same size as F applied? I think smaller. What if I had said we're pulling but not going anywhere? Then friction would be same size. Can't be bigger. What if I said slowing down? Then friction would be bigger. And I would look for that and just exaggerate it. But here, I'm pretty sure it's that. Gabe, how many arrows did I just draw? What's this question worth? Half mark for each arrow would make sense. And those questions that I just asked you, I think, Alex, that's pretty much every possible one I can come up with, Alec. I don't think I can come up with anything else. Find the acceleration. Oh, Alec, who's winning? Who's losing? And you'll notice we don't stick mg into it. Like students are always, don't have to stick mg in. It'll show up if it needs to show up. The tug of war is horizontal here, so just write a horizontal equation. Or when there's more than one mass, write it along the rope. It'll take care of itself if you need to. So you're telling me, and I think you're right, by the way, A is going to be F applied minus mu times the normal force divided by m. A is going to be F applied minus mu, I don't know the normal force, in this case it is mg divided by m. And if I go to, what do I have? 225, Mr. Dewick, minus mu times 100 times 9.8 divided by 100. You get 0.78? This is almost in balance. Probably this friction should be almost the same length as F applied because we're barely accelerating at all. But we are. What if I got, before you turn the page, what if I got a negative answer? Friction's winning. Quickly redo the question. Just adjust your arrow lengths, change your winners to losers and losers to... It's a pretty easy fix. So I'm so lazy, I rarely try and figure it out ahead of time. I usually assume F applied is winning, and I'll find out if I'm wrong. Give 2 out of 2 if you got that. Otherwise, I would give a half mark here, a half mark here, half mark, half mark. And now you can turn the page. Jared, what does A want me to find? V. You know what this is a good job for? Say, hey, you haven't forgotten everything. You're back in rare form. What are the forces acting on the first one? Since there's more than one mass, I'm going to call it M1G. And I'm going to call it normal force number 1 to go with mass number 1. There is a rope. What do we typically call the force from a rope? Yeah. And is there friction? Well, there's a mu, so let's assume there's friction there. M2G. Tension. Who's winning? Mr. Dewick, this mass is smaller than this mass. How is it possible for M2G to be winning? Doesn't M2G have to be bigger than 6.3 to win? No, not if we're hanging over a cliff. If this was on ice, because what's holding this mass back, Irina, is friction. If we were on ice, this could be 1 kilogram, and I'm telling you, it's still pulling it over the cliff. If we were on perfect ice with no friction, you're moving still. So as long as friction is smaller than M2G, and that's really the tug of war, it's between those two, and I should have called this friction force number 1 to go with mass number 1. It doesn't matter if this mass is smaller as long as when you crunch the force, it's bigger than the friction force resisting it. Who's winning? M2G. Who's losing? Minus tension, plus tension, minus friction force number 1. Do I have forces from more than one mass? I better have more than one mass. Oh, stretch. A is going to be M2G. It's going to be divided by the mass of all of them, M1 plus M2, minus mu times the normal force. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. mg. Mr. Dewick, yes, Jordana, could you give us one of these with an extra vertical force so that the normal force wasn't equal to mg? I think I did in your homework. Physics 12, absolutely. Physics 11, I don't know. If I wanted to make the test more difficult, maybe, but I don't think I will. Okay? So it's going to be... We got more room to go down one more line? I do. You know what? Let's go sideways. A equals m2g minus mu m1g all over m1 plus m2. A is going to be m2, 4.6 times 9.8 minus m1, 0.19 times 6.3 times 9.8 all over 6.3 plus 4.6. What's my built-in error check? What's the biggest the acceleration can be for this hanging mass? Yep, ain't gonna be bigger than that if I get an answer bigger. You get 3.06. Okay, and so if I had accidentally, for example, put a plus sign here, oh, you don't get bigger than 9.8. That doesn't catch that error, but it'll catch typos. Anyways, 3.06 meters per second squared. Which mass would you use to find tension? I'd probably go with the 4.6. It's cleaner. So I'd probably say, oh, part marks, by the way, 1 mark, 1 mark, 1 mark. Sorry. 1 mark, half mark for the numbers, half mark for the answer. Again, I'm much more concerned. Can you set it up? So I'd go M2G minus tension equals M2A. I would now swappy dance. I would go M2G minus M2A, and I would tuck the tension there just for giggles. And it's going to be 4.6 times 9.8 minus 4.6 times, I'm going to write 3.06, but I'm going to use my answer button. You get almost exactly 31? No nods? Yes? 2 out of 2 if you got that. Otherwise, I would probably go, oh, I don't know, half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. So I told you last day I have decided I am going to put a missing mass question on your test. These are tricky. I should make them worth a bunch of marks because, Jimmy, they are tricky, but I'll probably make it worth like 2 just so it doesn't hammer your grade too much, I think is what the plan is. What's my strategy? Because they didn't tell me mass 2, I'm going to first of all do a free body diagram and analyze mass 1. Jimmy, what are the forces acting on this 4.2 kilogram mass? Get the obvious one. So I'll call it M1G, normal force. And then there's a rope. What do I call the force from a rope? You're feeling it right now. Starts with letter T. Uh-huh. Is there friction in this question? I think the wheels are meant to indicate ignore friction. So which way is the 4.6 accelerating, Jimmy, my friend? So which force must be winning? Which force is pointing to the right? Which force is losing? Trick question. Which force is losing? It's a trick question. Nothing. So it says find the tension in the rope. Tension equals M1A. This is kind of nice. I don't have to do much fancy. I can get the tension by itself. It's going to be M1, 4.2, times 3.2. Tension is 13.44. 3 marks for that. Cool. I would probably go 1 mark for that, 1 mark for the numbers, and 1 mark for the answer. Now it wants me to find the mass. Okay. What are the forces acting on mass 2? M2G tension. I'm going to write an equation just for mass 2. Which force is winning in mass 2? I think M2G, because mass 2 is accelerating down. So it's going to be M2G minus tension equals M2A. Matt, what am I trying to find in B? How many M2s do I have? How many would I prefer? Get them to the same side. I'm going to do the swappy dance. That's going to give me M2G minus M2A. How many M2s do I have? How many would I prefer? It'd be really neat if there was a Math 9 operation that I could pull out of my back. What? I can factor out a GCF. I'll get M2 bracket G minus A equals tension. And so now to get the M2 by itself, just divide the bracket over. M2 is going to be tension divided by G minus A. It's going to be 13.44 divided by 9.8 minus 3.2. You get 2.04 kilograms. And I would probably do for 3 marks, 1, 2, 3, 4, 5. I would probably go half mark for that, half mark for that. I would give you 1 mark for the factor trick, half mark for that, and a half mark for the answer. Can you give yourself a lovely score, please, out of 27? Take a look at the study guide that I just gave you, the forces review. So I like number 1, I like number 1, I like number 1. Number 1 is a nice question. Number 2, there's absolutely going to be an elevator question. Chase. Thank you. There's absolutely going to be an elevator question on your test, probably more than 1. In fact, probably I'll do one where they're accelerating up. I'll probably do one where they're accelerating down. I'll probably do one where they're in free fall or at a constant velocity or something like that, okay? What's the what's the mass of this person in question number 2? Is their mass 800? First of all, that would be high. How would you change that into a kilograms? Okay, so I will at least once on the test, Matt, instead of giving you an object's mass, I'll give you its weight in newtons, which is mg. Okay. There's going to be an Atwood machine, so 3 is good. 4 is good, finding a mu. 5 is good, finding a mu. 6 is good. Do a good free body diagram. This is asking me to find lift force. I think in your free body diagram, I think lift force is going to be the arrow up, and you'll get that arrow by itself, whatever we call it. Okay. 7 is good. 8 is good. 9 is good. There was a question I wanted to... So definitely 11 and 12 are really, really good. 13, 14, 15, that tells you what I can do with net force. Okay? 15, I'm asking you to find the acceleration due to gravity. I'm asking you to find... Sorry, 16. I'm asking you to find the acceleration due to gravity. I'm asking you to find little g. What equation have we used this time? Oh, screen's frozen because I'm stupid and forgot to unfreeze it? Duh. Thank you. I'm asking you to find little g for number 16. What equation has a g in it that we've used in this unit? It should be fairly obvious. Which equation has a little g in it that we've been using all unit? It should be fairly obvious. Really, people? What? Yeah, the obvious one. So if I give you the weight, this time I gave you the mass, could you figure out the acceleration on the other planet? The little g? Divide by m. And then once you know little g, you can find the weight on the mystery planet. Just to let you know other applications of this stuff. Okay. Elevator question 17 is good. These are all pretty good. The one I want to talk about is, so number 20 is a find a missing mass question. Tricky. 21 is find a missing mass question. Tricky. And I think the rest are good. You can decide whether you want to write your answers and work on this sheet, because you can label the pictures, or on a piece of paper, or some combination of both. You may find some of them you have room to show your work on the paper, some of them you don't. It's whatever works better for you. I don't care. I'm going to shut up. You got a half an hour to work on this, and you'll get most of next class to work on this.